everyone, in today's lesson we're going to review the limit definition of a derivative. So in the beginning, before power rule, quotient rule, chain rule, before all of those derivative rules, we defined a derivative, f prime, as the limit as h approaches 0 of f of x plus h minus f of x all over h. So I'd like to go back to that definition and use it to find a derivative. So example number 1 says, find the derivative of f of x using the limit definition of the derivative. So I'm going to give you an f of x function. So let's say f of x is x squared minus x plus 7. And I want to find the derivative. Obviously, everybody knows the power rule, and you know that by definition of the power rule, our derivative is simply 2x minus 1. We take the power, bring it in front, drop down the exponent by 1, and the derivative of negative x is really just the coefficient, so negative 1. But if I'm asking you specifically to use the limit definition, this technically is not suitable as an answer. So, if I want to find the derivative using that limit definition, the derivative is equal to the limit as h approaches 0 of f of x minus h minus f of x all over h. So the f of x plus h is everywhere I see an x, I'm going to put an x plus h. So it would be x plus h squared minus x plus h and then plus 7. And this part says minus f of x, which is the original function. So we would do minus x squared minus x plus 7. And then we would simplify using algebra. So we would simplify this by double distributing. Just for purposes of time, the double distributing I'm just going to write. It's x squared plus 2xh plus h squared. We're not going to forget to distribute that negative. So minus x minus h, then plus 7. And we're not going to forget to distribute that negative. So minus x squared plus x minus 7. And then all over h. And I know it's annoying, but we always have to remember to write down f prime, the limit, as h goes to 0. And we can combine like terms and cancel stuff out. So this x squared with this x squared will cancel. This x with this x will cancel. And those 7s will cancel. So we're left with 2xh plus h squared minus h all over h. Again, we're bringing down f prime of x is equal to the limit as h approaches 0. And we're going to divide each singular piece by h. So when you divide these two by h's, these h's cancel. One of these h's cancel, and these divide out to 1. So my f prime as the limit as h approaches 0 is 2x plus h minus 1. And then the last and final step is plug in h is 0. So if I plug h is 0 here, 2x plus 0 minus 1, we just get 2x minus 1 is my f prime, or my derivative. And that's what we said before, what we were going to get. But again, obviously, if I'm asking you to use the limit definition, you have to go through this whole process. Okay, so I needed to review this so that we could answer questions like this. So question number 2 is saying, find the derivative given the limit. So now instead of me asking you to use the limit definition to find the derivative, I'm saying, here is a limit and find the derivative. So you actually don't have to do what we did in example number 1. We actually just have to compare this limit that's given to the limit definition of a derivative. So if I write it below, we know that f prime, or the derivative, is equivalent to the limit of h approaches 0 of f of x plus h minus f of x all over h. So if we can take this definition of a derivative and analyze it to the information that's given, we can pull out some real important information. So this part, f of x plus h, is all right here. This is where they plugged in x plus h. So it's 3x plus h squared minus x plus h plus 10, and then minus, and then after the minus is your original f of x function, and then all over h. So if we wanted to even write that down, this is your f of x, this is your f of x plus h. So if they want us to find the derivative, well, we just need to pull out what f of x is. And f of x is this. So my f of x is 3x squared minus x plus 10. And if I want to find the derivative, all I have to do is multiply the powers in front. That would be 6x, and then minus 1. And this is my derivative. Again, it's not saying use the limit definition. It's saying given the limit, find the derivative. So I'm just using a little, I guess, deductive reasoning skills, and I'm saying, okay, this is f of x, find the derivative, and we're done. All right, let's try another one. All right, so now same concept, find the derivative given this limit definition. So if we follow that same pattern, this has to be my f of x plus h minus this is my f of x. So if I want to find the derivative, I'm going to pull out what f of x is. So my f of x is 2x plus 7, and I want to find my derivative. Well, it's always helpful to write a radical as an exponent, so I'm going to make this 2x plus 7 to the 1/2. And when I take the derivative, remember I take the exponent, bring it in front, so that's 1/2. Keep the 2x plus 7, and drop this power down by 1. So 1/2 minus 2/2, which is 1, is negative 1/2. And then don't forget, we have to take the derivative of the inside. This is called the chain rule. The derivative of this inside is just 2. And when you multiply this 2 and this 1/2, they will cancel, right? This top 2 with this bottom 2. And then my final answer for my f prime is just going to be 2x plus 7 to the negative 1/2 power. And remember, another way to write that, if I have a negative power, I can bring it on the denominator, 2x plus 7, with a positive 1/2, or I could even write it as 1 over the square root. We don't need the 2 really when I do a square root, but 1 over the square root of 2x plus 7. And that is my derivative. That is my f prime. All right, let's try another one. Same concept, but now I have trigonometry. I want us to find the derivative. So if we analyze this difference quotient, we're going to see that this is my f of x plus h minus this, which is my f of x. So if I want to find the derivative, I first need to say what f of x is. So f of x here is sine of 3x, and I want to find my derivative. So remember, on the side, we should probably write down sine, cos, negative sine, negative cos. Remember that derivatives go to the right. So if I want to find the derivative of sine, I look at the s and I go to the right. The derivative of sine is cosine. So we write cosine of just 3x. And then this is another chain rule where we have to take the derivative of the inside. So that would be 3. So my final answer here is going to be f prime, or my derivative, if I want to write it nicely, would be 3 cos 3x. All right, last example, another trig function. So again, this part up here is my f of x plus h. This part over here is my f of x. So if I isolate what f of x is, I know that it's tangent of 7x. So if I want to find the derivative, I need to remember that the derivative of tangent is secant squared of the stuff that's in the inside, then times the derivative of the inside. And the derivative of 7x is nothing other than 7. So my final simplified answer is 7 secant squared of 7x. And that is finding the derivative, analyzing my difference quotient. All right, that's it for today. If you have any questions, please let me know.